Let's take a deeper look at the SCA Cupping Form from a scientific and particularly a statistical point of view. It is a preference data collection protocol, which is often presented and used as a descriptive protocol. It's not a descriptive protocol because it focuses on preference data and not intensities. Another problem is that the preference data are collected by a small group of people who are not aware about their own preferences and related to any possible consumer segment downstream where the coffees are later sold. So the difference between their preferences and the potential consumer preferences downstream is not a conscious part of the protocol. If the preference analysis does not reflect on possible preference differences downstream where the coffees are later sold, it is not a good model for preference predictions of specific customer segments. For many segments, there might be an opposite relationship between the preference of a customer segment and the preference of a few people coming from a universal cupping score. How often have you not had a coffee rejected by a consumer because this does not taste like coffee, it tastes like fruit juice, or it tastes like tea, or these kind of complete discrepancies between what you prefer and your customers prefer. The final cupping score of the SCA cupping protocol is often just the random preferences by the few people, sometimes only one Q grader, that are elevated to universal heights where they do not belong. It is neither descriptive, which would happen to be based on intensities if it was, nor useful from a consumer study perspective, even though most often the data from such an analysis is interpreted as describing the coffee and implying to predict that if this one random person liked it, it must be good and preferred by the general public. Both claims are wrong. In order for the community to progress, we should drop this old form altogether and start working with separate method when we describe intensity differences and map consumer preferences. If we mix these two types of descriptors in one method, we get one catastrophe that blurs the picture as such a fundamental level that nobody knows what's going on, and we don't have the vocabulary to even clarify the discussion and the methods. The SCA Cupping Form is by far the most problematic single entity created in the sensory realm of specialty coffee when it comes to applying fundamental scientific principles of sensory science developed in the 70s. We did not come up with this. I wasn't even born when these principles of scientific sensory science was developed. It is time to embrace the fundamental distinctions of sensory science and apply it in our community. To clarify even deeper and focus on the fundamental two different types of data in the inner world of a sensory perceiving human being, there are two fundamental different categories of sensory descriptors: intensities and preferences. Starting out with intensities, they are mapped out by a small group in a lab they are calibrated on intensity scoring of specific descriptors, and therefore you just need enough to compensate for the big variation you typically have in the sensory data, because you are trying to estimate some parameters in the samples that are there. So you're measuring, you get variation, and you just have enough to compensate for the variation. And remember, variation is not a problem when you are mapping out a parameter that truly exists, as differences between samples with big variation in the data can still be found by making a lot of repeated measurements of the same food substance, and slowly you start to trust the differences that you see on the averages of each sample, if differences are there. But you need to beat variation with replication and repetition before you can be sure. And the p-value will tell you when you can be sure about the differences that you see. Anything less than 10 people doing repetitive tastings typically don't find a relative difference in the samples, if it's even there. This is what empirically what we found in our sensory profilings. If you have less than 10, you typically don't get low p-values. So Therefore, it's important to recruit at least 10 people for a tasting. We typically recruit 12 to be sure, because having less people just is not enough to find a difference, even if it's there. And then you might end with the wrong conclusion that there is no difference, even though there is a difference. But you just don't find the difference that's there because you haven't been looking with enough people to create enough repetitions to find a small difference if it's there. So running something with a sensory project with too few judges, you will end up with the possible wrong conclusion of not finding a difference even if it's there. That's the risk of running with a too small panel. You don't risk to get small p-values with a small panel, because if you don't have enough repetition with a few people, you'll never get a low p-value. You only get a low p-value if you've got huge differences with a few judges. And that's a very important distinction. So the risk of having too few is not finding a difference even though it's there. So the difference might be there. It might be that there was a difference, but you just didn't look thorough enough. So say anything less than 10 is not a serious and responsible setup, as you might miss a difference that was actually there. Even worse is when you set up with only 3 or 4 coppers, and then you see p-values reported below 5%. And this is where it becomes really tricky, because either they are tasting samples with differences so big and obvious that you perhaps didn't even have to run the sensory investigation in the first place on this, or there have been some fiddling with the data to report these amazing small p-values in such a thin data set with so few coppers. Remember what I said, the risk of running with small coppers is that you are missing a difference that is actually there. If you get low p-value with few coppers, that's just not probably relevant, or it's something that would probably not happen. And a good example, would you trust somebody if they claim to have been throwing a dice 20 times and told you that they got 6 on each and every throw? Either the dice is broken or the data has been fiddled with. It's just not something that happens with any significant probability. Preferences are mapped out by choosing a specific customer segment for those for whose preferences are of interest. And this is looking at the number of people you need in a consumer study. So in a consumer study, preferences are mapped out by choosing a specific customer segment whose preferences are of interest in your project. In order to get good data, it is typically budgeted to get at least 70 customers, and preferably above 100 customers. Anything less and you don't get good results, neither when it comes to estimating the parameters well enough, which is the preferences typically, nor to feel that your sample is representing the bigger specified background population you are trying to map the preferences for. These are the more technical requirements for a good consumer study, but even more important, it is the conceptual fact that you should not expect that you can predict preference outcomes without asking different consumer segments. And you should expect to get a lot of different answers from different consumer segments, even within the specialty coffee business. This is the biggest error in the specialty coffee business, and this is institutionalized in the SCA Cupping Form. It is simply not a good model to predict the relevance of anything, since there is no built-in in the method to relate the quality score of the form to the problem of the consumer diversity. Specialty coffee people assume that they are right and not interested in what somebody else might think. We explored this in the research project that ended up in the British Food Journal as the paper with the title "Quality Does Not Sell Itself," where we had more than 200 customers as the basis of our data set. So every time you talk about quality, you talk about quality for someone. And if you have a method that is not specific about who that someone is, and have as an integrated part of the method to relate your result to these somebody as opposed to somebody else, then it is a bad theory that leads us nowhere. From a product development perspective, it might be good as at predicting what another specialty coffee person would think of the coffee, but even this the method failed to do. The only published data we have access to from the SCA Cupping Form is the data in the SCA freshness study. So let's have a deeper look at these with the methodologies we've covered so far. In the report, the coffees are claimed to have an import cupping score of 83.25 for the Colombian, 84 for the Brazilian, and 86 for the Rwandan coffee. In statistical terms, the cupping score is a parameter estimate of the quality of these particular coffees by evaluating a smaller sample that represents the total amount of coffee in the container. Assuming that this parameter exists and lends itself to sampling, which could estimate its true value, the question is, how well does it seem that the data at hand predicts that parameter? Hopefully, it predicts it within a nice and small range where the reported value from the importer is included in the interval predicted by the data of the sample. If not, the method is not good. If there's a discrepancy between what the panel finds and the number reported by the importer, it seems like it's not an objective method where different people will come up with the same number, right? So let's look at the data. I recreated the score for the setup from figure 19, where different packaging was tested on the Colombian coffee. I took the data from day 15 because this was the first column with an amount of coppers that was big enough to be interesting at all. Day number 3 only had 4 coppers, from which no interesting statistic can be derived. And also because coffee is less than a week from roasting is too fresh to peak in quality, in my opinion. So I felt that 15 days was relevant. So I would expect a preference peak around 2 weeks after roasting rather than 4 days. I was only interested in evaluating the method as such and would like to know how well the method estimated the cupping score from both an average and variation perspective. The average value of the scores should be close to the reported import score, and the variation of the data should give us a narrow confidence interval around this average, as we have 16 coppers in the study, which is a lot for a laboratory setup. This means that the true estimate for the average is expected inside the range of the 95% confidence interval, and we expect a narrow 95 confidence interval based on the big amount of coppers. So let's have a look at the data. As mentioned, the Colombian coffee was reported to have an import quality of 83.25, and the average quality score of the data at day 15 was 78.6. And conceptually, this is really critical because the reported quality score of 83.25 seems safe on the cutoff point of 80 for specialty coffee, and 78.6 is quite a bit lower for that cutoff point, and on the wrong side of the cutoff point for the scoring for specialty coffee. The number of coppers on day 15 was really big, namely 16, which is significantly bigger than our requirements of 10. And from such a big panel, you would expect precise data, even in a data set with big variation and only small sample differences. The calculation of the confidence interval is based on a combination of the variation and number of coppers, and that is why it is worth mentioning that it was a big group of coppers. Calculating the 95% confidence interval for these data shows that the lower cutoff point of the confidence interval is 75.5 and the upper is 81.7, which is really a bad result for the method, or also really bad for the reported import score of 83.25, because the reported import score is outside the 95% confidence interval. It's actually 1.5 points outside the 95% confidence interval. Not to mention the problem that the import score deviates 4.6 quality score points from the average of the data set. I know that the data in figure 19 is based on less trained coppers than the data in figure 18, which could have been interesting to look at, but visually I was not able to identify the individual numbers in figure 18. And if you look at the general spread in both figures, there's not a reason to assume that the skills of the coppers in these two sessions are different because the spread seems equal. The coppers are reported to be experienced coppers who self-identify as one who cups 3 or more times per week and scores coffee based on the SCA quality assessment form. So it's really experienced coppers using the form 3 times a week. If the method does not work for coppers with this professional profile, I don't know who it would work for. I would say that this is a big problem for the method, as it falls in the fundamental purpose of why it is created in the first place, as a global objective method to describe and predict quality score. It fails in exactly the meaning of objectivity described in empiricism. If different people follow the same method on the same object, here the coffee, they don't get the same result. Even the fundamental question whether the coffee is specialty or not is all over the place when looking at the data. I'm definitely not critical overall of the work with the sensory data from the freshness handbook, as they are doing linear regression over a lot of days. And the beauty with statistic is that variation as such is not a problem if you have a big enough data set, which is the case across all the days of tasting. But it is a weakness of the method as such that it is not able to provide better data for a single day with a specified coffee with 16 tasters trying to estimate the central parameter of the method. I have now seen several scientific studies using the SCA Cupping Form, and it really annoys me. The first problem is, of course, that the result in itself is useless because it's not clear how to use the result, because it fails to specify which customer groups the quality claim refers to be relevant for. One thing is that the result is not relevant at all, but if you suspect cheating, it is a fundamental violation of the scientific tradition. Remember the basic numbers I gave you for respectively a laboratory descriptive analysis and a consumer study. In order to get useful data with either a narrow 95% confidence interval or low p-values, you would require at least 10, preferably 12 coppers, or 70 or preferably 100 if it's a consumer study. Often I see 3 to 4 coppers, Q graders are often used, and low p-values in a dataset where I expect relatively small differences. And remember here that small differences are expensive to map out because you need much more people to create much more data if a small difference is to be mapped out with precision. Would you trust somebody if they told you that they got Yahtzee 3 times in a row in the first row every time? The probability is just so low that you would not trust anybody claiming this purely out of your intuition about how parameters with inbuilt random behavior, how it works. You get suspicious and would like to check if they fiddled with the dices or just simply reported the wrong numbers. I'm sorry to be so blunt, but after having overseen several sensory descriptive analysis done at the university and by IDA, this is just what I can't help thinking. Think about the Yahtzee example above, and you would know how I feel. The only situation where you could get away with getting so certain data with few coppers would be that you are testing sample with such a big difference that it's almost not worth doing the study in the first place. Huge rose color differences, for example, in which case you are more interested in the size of the difference than the fundamental question if there is a difference at all. The technical explanation of how the SCA cupping protocol made it to any scientific journal is that they are all published in journals with a focus on chemical analysis, in which case neither the editor nor the reviewers knows deeper about sensory science and fails to apply the critical scientific thinking they use when dealing with chemistry, probably because they don't expect much from a so-called science dealing with subjective experience anyway. And I guess that this is what really annoys us, that sensory science is not considered a science, even by other scientists. The loser in the coffee is the coffee community. They run with the idea that there is a direct universal quality consequence of different technical aspects of process parameters. Now I've clarified my thoughts about this, and I hope I'm wrong. I don't hope that anybody has been fiddling with data in the scientific papers I'm talking about, and I hope there's something I've misunderstood. But until somebody convinces me by using proper scientific concepts, I'm sorry to admit that I can't see any other conclusion.